Obviously, you know you're in the right place because we're in a packed house. Sorry for everyone standing, but this is going to be a good one. I'm Bowden Kelly. I'm a program manager on the TypeScript team. Despite what Frosty said earlier, program managers do have good intentions most of the time. We are stationed in Redmond, and I'm here today to talk about TypeScript, the language that you already know. So let's just jump straight into it. The one thing I want you to take away, I'm going to show you a lot of cool stuff about TypeScript and even some stuff about JavaScript. But the one thing I want you to take away, if you take away nothing else, is why TypeScript. For those of you who are veterans in the JavaScript world, you know that there's a lot of choices. For those of you who are new, you're probably overwhelmed with all the choices. There's lots of tools. There's lots of libraries. There's lots of frameworks. It seems like every other week there's something new that you have to decide whether you want to even learn it or not, let alone use it. And I want you to leave this room understanding why TypeScript deserves your time and why you should give it a shot. And so why? Why TypeScript? From our perspective, it's pretty simple. We think that developers should be able to focus on creating amazing things. And creation is bolded here because that's the key. That's why we're all here. No one's passionate about triaging GitHub issues. No one's passionate about refactoring code. We like creating amazing new experiences. And we think you should be able to focus on that. But unfortunately, that's not exactly the case. When you look at how developers spend most of their time, and I encourage you to, over the next couple of weeks, actually keep track of what you're doing day to day, you'll find that there's three big categories of activities. You have an understanding, which is just reading up on news, keeping track of trends, learning about existing code that you may support and not be aware of. You have maintaining, which includes fixing bugs, tracking bugs, preparing your code base for new features, refactoring, and the sorts. And finally, you have creation, which is building entirely new experiences, which is what we want to do in the first place. And we find that with JavaScript in particular, the more JavaScript you have, the more time you spend understanding and maintaining and not creating. And at Microsoft, we started tracking this on some of our JavaScript repositories and found that we were spending 95% of our time just trying to understand and maintain what was already there. That's 2 hours out of a 40-hour week that you actually spend delivering new value and making cool new stuff. And for us, this meant that our code bases became more or less read-only. The risk of making a change to a JavaScript code base was so high that you might introduce a new error or you might not understand how it would affect the rest of your application that it almost wasn't worth touching in the first place. And we started looking at this. We said, how can we fix this problem? Obviously, we want to keep using JavaScript. JavaScript is awesome. Right? You can build mobile apps. You can write server code, front-end code. You can do everything with JavaScript. There's a reason why it's the most popular language in the world. So we wanted to keep JavaScript. But we thought, how can we build tools that can help us? What can we do to take this distribution and make it look something more like this? Where using tools, we can shave off a little bit of time in understanding and maintenance and feed that back into creation. Chasing that dream is why we created TypeScript. So what is TypeScript? The technical definition is it's a statically typed superset of JavaScript that compiles to plain JavaScript. So when you leave this room and someone says, oh, you must know what TypeScript is, what is it? You can either vomit this back out at them, or you can show them this quick 101, TypeScript 101 I'm about to show you. So I'm going to crack open a JavaScript file in VS Code. If you're familiar with VS Code, it's awesome. If you're not, thank you. Let's try. There we go. Is that big enough? Awesome. If you're familiar with VS Code, it's great. If you're not, I encourage you to check out Wade Anderson is doing a session later this afternoon on VS Code. I encourage you to sit through that and check it out. VS Code is where I've been spending most of my time lately. It's a fantastic lightweight editor, and I encourage you to give it a shot if you haven't already. But here we have just a random JavaScript file that we pulled from a random project. And it's very normal, very average. We have some functions. We have some variables, some if blocks. Nothing crazy going on here. When you get started with TypeScript, all we're going to do is rename this JS extension to TS. And boom, you're done. That's it. TypeScript 101, you passed. Go update your LinkedIn profile. You are now a TypeScript expert. But there's more to just that, right? Like you don't want to just, rename your extensions just for the sake of it. What does TypeScript do for you? Well, as you can already see, we have a red squiggle here. And so what TypeScript is doing behind the scenes is looking at all of the types in JavaScript. JavaScript has typed. It's dynamically typed. It just doesn't enforce them. And they can change whenever they want. TypeScript starts to look at those and reason about them. And so if we look at parse int here, we can see that TypeScript knows it returns a number. If we look at email address, TypeScript says, I don't know what this is. This could be anything. And it's just basically using the rules of JavaScript to try to assign types to all of these things and reason about them behind the scenes. And then using those types, it starts to tell you when things look off, hence the red squiggle. So if we take a look at this, we can see operator greater than cannot be applied to the types. Function returns a number and a number. So TypeScript is saying, hey, you've got a function and you're comparing it to a number, and we don't think that's what you intended. And if we look at ship weight, sure enough, this function returns the parsed int of an element. So probably what we wanted to do was actually call this function and compare it to a number to see if our package is oversized. But what does JavaScript do? JavaScript sees this, and at runtime, it compares a function and a number. And it doesn't tell you anything about it. And does anyone know what happens when you compare a function and a number? It's false. Why is it false? I have no idea, but it is. And so at runtime, you have this code that you thought was going to be checking the weight of your package to make sure it's not an oversized package. And it's going to be false every single time. You're not going to get errors. You're not going to get warnings. You're not going to get anything except for a lot of user complaints that your application isn't working as intended. This is the perfect kind of error category that TypeScript is good at catching. It uses these types behind the scenes, and without making any changes to JavaScript, it can already tell you that something's off. Let's look at another example. Here we have this argument of type, an object literal with a value and a read-only property is not assignable to the parameter of type property descriptor. Again, what's a property descriptor? I don't know. There's no types in JavaScript, so what is that? Well, I can go look inside this defined property, and I can see what it's expecting. And here is that property descriptor we just read about. And here we have a TypeScript interface that is representing the object shape that JavaScript is expecting. And so again, in JavaScript, none of this is required. So you see TypeScript is saying all of these are optional properties. But these are the options that you have that are valid to configure this object. We have configurable, enumerable, value, writable, get, and set. And if we go back and look at our file, you can see we said read-only true. And so probably what we intended was to say writable false. That's an honest mistake, right? You think you remember what the API is, but you don't, and so you just take a stab at it. But what happens at runtime? At runtime, JavaScript sees a property that it doesn't use, and it just ignores it. And so here you think you have configured this object correctly, and in fact, at runtime, it's behaving in a manner that you did not intend. TypeScript is great at finding these type of errors and introducing them to you during your development loop rather than your testing loop. But again, this is all out of the box. We haven't done anything special here. This is all JavaScript, and TypeScript's already giving us some value without making any additional changes. But what happens when we start teaching the compiler more? I mentioned earlier that there are some things that the compiler just doesn't know. Right? Here we have a parameter, and TypeScript is saying this is type any. It can be anything. Right? Because in JavaScript, you can pass in whatever you want to any function at any time for any reason. But what we can do is we can look at this comment and see that the author intended to have a string or a string array. And we can tell TypeScript that this is going to be a string or a string array with what's called a type annotation. And now this type annotation is going to pass this information to TypeScript, and then these types are going to spread through the rest of the function body. And so everywhere where we look at this email address, we now know it's a string or a string array when previously we didn't know what it was. And sure enough, we've already found another error. Now that we know what the type is, we can see that inside this type guard, which is checking to see if it's an array, TypeScript knows that email address must be a string array and can't be a string. And in the else block, you can see that it's a string because it's the only other option remaining. And because we know these types, we can now pass them all through this for each block. We know what value and index are, and we can see that value is of type string. This is all with one type annotation. And of course, this is a misspelling. Trim is 1M. But JavaScript wouldn't find that for you. But TypeScript will. And this is all at compile time, and will save you the effort of finding this at runtime. And so that's pretty cool. And so we've done now a couple of things that have made this not JavaScript anymore. We've added these type annotations, and they will no longer work as JavaScript. And so what TypeScript does is when you compile this, and I'm going to configure VS Code real quick to compile my TypeScript file. When you compile this, it's going to strip out all the types and give you back the exact JavaScript you started with. So here you can see the only difference really is that we have stripped out that type annotation, email address, and returned you the exact JavaScript you wrote in the exact format that you saw it. We don't minify it. We don't rewrite any of the things that you give us. We try to make it as human readable as possible. So at runtime, the JavaScript you're running looks like you would have written it yourself. And we think that's pretty valuable. So jumping back into our slides here, hopefully now you understand what this statically typed superset of JavaScript that compiles to JavaScript means. It's a statically typed superset in that we lay types on top of JavaScript. You start with JavaScript and you add types optionally wherever you want them. And wherever you do that, TypeScript then assumes that you want those types to be static. And then at runtime, you can compile it back down to JavaScript so you have the same JavaScript that runs in every browser, on every platform, on every OS. And so the key of this is you can start using TypeScript today. You can use it in one file. You can use it in all your files. All you have to do is rename your JavaScript files to TypeScript, and you're already off and running. And you can use that to get compile time error checking to save you time at editing time rather than runtime for catching small slip-of-mind bugs. You can improve the ability for TypeScript to work for you by adding optional types. And by doing so, you get the benefits of being able to refactor across project. You can use advanced tooling features that only come with statically typed languages. And you have an overall more productive editing experience. So you can spend more time creating cool stuff and less time maintaining your existing code. But the big takeaway from that first demo is that JavaScript is TypeScript. And I can't ignore the importance of this enough, because a lot of people will look at TypeScript and see the types and think, you know, I've got a Java background, I've got a C# background. You know, I can learn TypeScript and not JavaScript and feel more comfortable. And that's not the case. Because TypeScript is built on top of JavaScript, it's crucial that you understand the basics of JavaScript to be successful with TypeScript. Because that's, at its core, we are just wrapping that type system on top of JavaScript, passing it through the compiler, and you're getting JavaScript back. So you're still working in JavaScript. We're just giving you additional safety on top of it so you can spend more time creating cool things. For those of you who've been following the evolution of JavaScript, is anyone here familiar with ES6, ES7, or 2015? For those of you who aren't, JavaScript is a continually evolving language. Every year now, they're trying to release an update to the language. In 2015, they released ES6 or ES 2015. This year in June, they just released ES 2016 or ES7. And they're going to continue to do this every year. And why this is important is because if you want to use these new features to be more productive, you need to understand if they're going to actually work at runtime or not. And unfortunately, that's not exactly the case today. And so we have this situation where the state-of-the-art JavaScript, where you can use classes and decorators and object rest spread and all of these advanced features, are kind of way off to the right on this graph. We have server.js or Node, which adopts these features at their own pace. And then we have the web, which consists of a bunch of different browsers and JavaScript engines, which adopt all of these features even at their own pace. And so at any given time, you may want to use these features, but not necessarily be sure if they're going to actually work at runtime. And so what we call this is the JavaScript Feature Gap. And this is always going to exist, because while today, the state-of-the-art JavaScript might only be ES 2016, tomorrow, it's going to be 2017. And browsers are going to still be working to catch up to those features. And there's always going to be this gap where there are features that we want to use that haven't been implemented by browsers, but that make you more productive. And so what TypeScript does is it takes all of these future JavaScript features and it wraps them all up. So when we say TypeScript is a superset of JavaScript, it's really future JavaScript. It lays that type system on top of everything. And then as you saw, when we strip out those types, we also take any future JavaScript and compile it back down to ES5 JavaScript. And this is pretty cool because what it allows you to do is use features like classes. And so real quick, I'll just say es6.js. And this is a JavaScript file, not even a TypeScript file. We'll say class, person, and we'll create a constructor. And we'll say he has a name and an age. Oops. And we'll say, and so we'll just create a basic, ES6 class, which normally would not work in all browsers. Modern browsers it'll work. IE 9, it will not work. Mobile Chrome, it will not work. Mobile Safari, it will not work. Why do I know all these things? Because I wake up every morning and I read this chart. But we hope that you don't do that, because this is terrible. And keeping track of this, which is ES6, versus this, which is ES5, versus this, which is a lot of red, which is ES7, is a headache. And you shouldn't have to worry about that. What you should be able to do is pick and choose things like classes that you think are awesome and you want to use, and you should be able to use them. And then at runtime, they should return to the lowest common denominator. Here you see an ES5 function-based class, which we know will run in every browser, all the way back to IE 7, I think. And so you get the benefit of working with the features you want, while the runtime reassurance that this is going to work everywhere like the JavaScript you know today. And so you can set up these projects where you can use TypeScript in some files. You can use it in all your files. You can leave all of your old code as JavaScript and slowly convert to TypeScript as you see fit. It's really a truly optional process where as you decide that you want to opt into a better, more productive editing experience, as you have time to upgrade your code base, you can. Or if you only want to write new code in TypeScript because it makes you more productive, you can do that as well. And we want it to be a setup where anywhere that you're writing JavaScript today, you can write TypeScript as well. And so we've put a lot of effort into making sure that the tools that you can write TypeScript are equally strong and supported. I showed you VS Code today. I personally enjoy writing in VS Code, but we have support for TypeScript in every major editor. Visual Studio, Sublime, Atom, WebStorm, you see all the ones listed here. There's ones not listed here that we have plugins for. We have an extremely strong community of plugin authors who keep all of their TypeScript plugins up to date, and we work very closely to make sure that all of the TypeScript support is equal across the board. Because the only point of using TypeScript in these types in your code is so that you get a better editing experience. And so without editing support, there's really, you're losing on your investment of putting types in your code base. I would encourage you to check out our community. We have, we're completely open source. TypeScript is free and will always be free. You can find us on GitHub. We do all of our development in the open. You can learn more about TypeScript on TypeScriptLang.org. I've only showed you minor features of TypeScript here, and there is so much more to learn. But again, it's optional. You can pick them up as you want to use them. You can opt in at your own pace. And you can find us on Twitter, Gitter, and Stack Overflow. Looks like I've got a couple more minutes. Am I allowed to take questions? Yeah, we'll take some questions then. Yeah?
So you said that, how can you guarantee that you'll be compatible with future versions of the JavaScript stack?
So what we do is we have multiple members of our team on TC39, which is the committee that drives the ECMAScript standard. And what we do is we keep track of basically the evolution of the language. And as things move through the stages of proposals, basically they have 5 stages, 0 through 4, where 4 makes it into the next release. Anything that reaches stage 3, something that becomes stable enough where we don't think they're going to take it back out, we then immediately put it in the language. So for example, object rest spread is not in TypeScript yet. It's not in ECMAScript yet, but we're working on implementing it now because our team members on TC39 have told us that they're pretty confident it's going to move to stage 3 at the next meetup. And so we're going to go ahead and implement it. Yes?
So go back to that
Yes.
So do all these just work out of the box if you edit a TS extension file, or do you have to load different modules?
Visual Studio and VS Code will work out of the box. WebStorm will work out of the box. Sublime requires a plugin. Atom requires a plugin. Emacs and Vim require plugins. We typically try to get support out of the box, but the smaller and faster the editor, the less they prefer to have preloaded, support for stuff. Yes?
Does future version of ECMA script have plans to add those type checking?
So that's a question we get a lot is, are types ever going to come to ECMAScript and not be, just in TypeScript? Probably, it's inevitable, not in the near future. Brandon Eich will say himself that in the next 10 years, we won't see types in JavaScript. It's a very complicated, highly debated subject, how it would work and how it would fit into the existing ecosystem. And so there is a lot of work that needs to be done to work it out, and it's going to be a very long process.
Can you talk about why I would use TypeScript over Flow?
Yeah, so TypeScript and Flow aim to accomplish the exact same thing. We're both trying to add types to JavaScript. That is, at its core, the goal that we're both chasing after, a better, more productive JavaScript experience. The number one reason you would use TypeScript over Flow today is the editor support. As it stands, they have a couple plugins for various editors. Last I checked and used them, they have varying degrees of quality. I know they're working on that a lot right now. They just added Windows support, which is a major step for them into kind of realizing a full-fledged ecosystem. But at the end of the day, we're both trying to accomplish the same thing. I would encourage you to try them both out. They have a slightly different style than we do when it comes to types, nominal versus structural typing. But as it stands today, we have a richer community, a stronger ecosystem of tools, and you'll have a better end-to-end experience with TypeScript than you will with Flow.
When you're debugging the file JavaScript, is it actually linked back to like line numbers in the TypeScript?
So what we'll do is we'll generate source maps, which is the same concept if you've minified your JavaScript. And so basically the source map tells the debugger that we've got this file that we're currently executing, but it actually points back to this TypeScript source. So when you debug, you see your TypeScript, but you're actually running that JavaScript. And if you have minified TypeScript compiled code, then you have multiple steps of source map, which just climb all the way back. All right, thank you so much.